option in Google to say flip the, it's how Hangouts works. So when you're doing this, it's like, oh, left hand, right hand. You're live.
You looked into some of the new easier streaming options to YouTube. There's apparently now a really easy way to do 4K streaming right to YouTube. Without having to have a third party, like, what's the common one? ODS or what's ODI? What's that one's called?
Broadcaster, open broadcaster.
Yeah, open broad. Yeah, there you go. Open broadcaster or OBS. That's what I was thinking. It's apparently a much easier way to do it now.
I haven't seen that.
A couple weeks ago. So one of my buddies told me about it. That's an easy way to do almost real-time streaming. We've been talking about setting up at work. We have remote office, of course. And I want to do like a portal, like from the game world, right? So I want to do like a 60-inch TV mounted vertically on a wall. I want it to have a real-time video connection to another site. But I want it to be, and of course you can do this with Skype. I mean, this is a thing. It's been on forever, right?
There's a lot of people who just leave video on all day with their offices.
But I want it to be as seamless as possible, right? And so we talked about maybe just doing it with multiple, but a requirement we have internally is it can't push out to an external server from a security standpoint, right? Unless that server is YouTube. or YouTube. So if we do that, I have a box here that is doing an upload to YouTube, and the remote office does the same thing, and we watch each other's streams, I wonder how real time that would be. I'll have to test it and see.
They'd have to be unlisted because private they wouldn't be viewable.
Right, we do.
Unless it's the same user.
And you can restrict it. I mean, you can restrict it by domain. So you can say only people with this domain account.
Just make it the same user. Because you should be able to watch it on stream.
That's true. We could do that. I don't know. Well, that's it. All right.
You're live.
Hi. Welcome to OLUG.
Yay.
This is November 2017. Jeez Louise. Can't believe it's November. You know that already. It's November. My name's Adam. I work at Google. Used to work at AIM, John, a long time ago. Used to work at, lots of other places too.
EPS.
I talked about that today I was for me. What's going on in the Linux world today? Anything exciting?
Sure.
What's going on, John?
Let's see. Fedora 27 was almost released. There's a little bit of a delay. Well, the more interesting one is.
So wait. What's new in Fedora 27? Why should I care?
New GNOME. So the new graphical environment.
What's it called?
GNOME.
Oh, new GNOME. Sorry, I misheard you. Okay.
And
have they gone Wayland yet, or are they still X?
They're moving more towards Wayland.
Yeah.
So I think this is the big push.
Okay.
The big thing is their Flatpak initiative for installing applications.
Really?
And 27 will be the beginning of the rolling release. There'll be no more Rawhide.
Okay.
Because it'll be nightlies. That's it.
That's it. No.
So they're also going to be getting rid of alphas.
Is Flatpak what alpha? Not okay. Alpha version.
Yes.
Is Flatpak replacing?
It's just like in addition to.
It's in addition to.
Yeah. So like allow application providers like LibreOffice to have their own little Flatpak version of the distribution that you could get the most recent version.
Why is that better than RPM and Yum?
I haven't read up on that.
Okay, I haven't either. So
I think it's more portability for probably putting it on a flash drive or whatever.
Oh, really?
Yeah.
Okay. Does anybody work with Flatpak at all? I haven't.
Maybe have to do a presentation.
Yeah, I don't know much about it.
The other one is Intel announces CPU with HBM2 memory and AMD graphics. So Intel and AMD are working together on a CPU.
Fight against Big Dad NVIDIA.
It's part of, hey, no one's buying x86s. Let's get together and make more x86. Because like mobile, right? Mobile's supposedly taking over for everything. But it's interesting to see.
Well, it's also a rationale for that is the hardware accelerator, long been the domain of gamers at home that are building video game systems to play Quake at higher FPSs, right? Has now become kind of a data center staple from a hardware standpoint.
Mm-hmm.
So companies like NVIDIA primarily, but also companies like Broadcom and AMD, of course, are really trying to get into the data center space for machine learning hardware support.
And AMD is positioning their CPU kind of like how they do the game processors for the consoles.
Yeah, we have a lot of hardware accelerators at the data center. It's a big deal.
There's more than 12 USB vulnerabilities published for the Linux kernel.
What kind of vulnerabilities?
Security vulnerabilities.
Yeah, I think
on USB.
Oh, by USB, really?
Yes.
Of all things?
14 known security vulnerabilities within the kernel's USB subsystem. Let's see, the good news about these vulnerabilities is that they would require any rogue individual to first have created a specially crafted USB device and have physical access to the system.
Okay.
So a little bit limited vector.
Already got physical access to the system, all kinds of things.
It's not unlike...
That's interesting, though.
Yeah, this one you might find interesting. Google even fear Intel ME reduced their attack vector with NERF. NERF is the non-extensible reduced firmware for UEFI. So it's a new BIOS essentially for systems with reduced instruction sets to limit their attack vectors on the hardware.
Yeah, I'm sure. I guess that makes sense.
Yeah, that was the last.
Meanwhile, I swear I saw something that said that maybe it was some Chromebooks that we're going to be using OpenBIOS.
Raspberry Pi.
Oh, that was from 2016. Once I opened the slide up, it refreshed from another screen. I had it being displayed while I was working on another computer updating slides.
That's interesting. That, yeah, UEFI stuff is cool. Such a pain in the butt.
Yeah.
I understand the rationale behind it, man.
Not quite as, I mean, BIOS has been around for a long time.
Long time, right? Probably didn't need an overhaul.
Yes. Was EFI a good overhaul?
Yeah, was that the answer?
Sort of, I suppose.
It was an answer. It wasn't the answer.
As much as I've worked with it was on older Mac systems getting Linux to boot on it.
Yeah, that's kind of where it was born, right? It's on their Macs. All right. Tonight's topic is regular expressions. The first question, of course, that you should ask any presenter, whether you do topics like this, is, what the hell's a regular expression? One of my favorite quotes, back from '97, when I was young and had hair. Some people have a problem, think, I know all these regular expressions. Now they have two problems.
Alt.religion.
I know, right? Jamie Zawinski. So here's a regular expression. A sequence of characters that form a search pattern. That's a pretty ambiguous description, right? But let's think about that for a second. What are we talking about, right? Well, first, remember, this is the Omaha Linux users, right? So we're probably going to talk about Linux. One of the hallmarks of Linux is a standard Unix tenet that has been around since Unix was invented, in that it's all text files, right? It's all text files, all the way down. It's all text files, all the way down. Or, more importantly, systems or hardware or sockets or whatever represented to you as a text file, right? They may not actually be an honest-to-God text file living on a hard drive, but who cares? If it's represented to you as a text file, you can use all the same tools that you already know how to use to parse the data, to make decisions based on the data, all the things we have to do as systems, right? I like to tell people that I've been working with Linux for 20 years. I know like 20 commands. That's it. I don't have to know any more than that, because all those commands are text manipulation commands. And that's all we do. That's all we do in Linux is text manipulation. That's it. Get it down to text, and I can parse the crap, right? Enter the regular expression. Okay? A sequence of characters that form a search pattern. A huge part of what we do in parsing text is searching for patterns, right? When you think about that, think about how much of your day is literally just spent searching for patterns in data. I give a lot of talks to kids about careers in information technology. I did this to a whole sea of 8th graders a couple weeks ago at Iowa Western. And I talk about what it means to work in IT. And one of the big things I focus on is the fact that
the tools change, the systems change, the technology changes. But what we're really doing as IT workers is we're pulling knowledge out of chaos. We're starting with this giant information dump, which we all have access to. It's a thing called the internet, right? Used to be really hard to get that data. Now everybody has this data, right? So a lot of it comes down to you just have to know the right questions to ask of the data. And you have to know where to get the data. And you have to know the format the data's in. And this is a big part of it. If you can get the data down to a simple format, like ASCII text, which has been around for how long, right? You can apply search patterns to that data. And there's a lot to be said for just being able to pull out information based on a pattern that you create to create what is essentially order from chaos. So that's where regular expressions come in. Regular expressions is not a simple command. It is, you can kind of describe it as a language unto itself because it's a way to represent data, right? You're trying, so much of what we do is trying to get a computer to follow instructions that we give, right? I mean, the holy grail, of course, is the Star Trek bridge computer, specifically from the Next Generation, because that's one. We all want to get to Star Trek TNG, the bridge computer, right? Where we just say, hey, computer, show me this, or hey, computer, do this. And we're close, right? We have tools like this, Google Assistant, we have Siri, we have Cortana, we have, what's Samsung's called, Bixby, I think, or something, Brigsby, I don't know.
Bixby.
We have all these tools. It's great for simple, you know, what's the temperature? When do the Golden State Warriors play tomorrow? Simple stuff like that. We got that covered, right? But it's the next step. It's that asking the computer to make decisions based on that data. You know, and you see this on TNG every once in a while. They'll say, you know, computer, what is that? They'll tell me, and they say some version of what do we do? And the computer goes, insufficient data, which means I don't know what the hell to do. You figure it out. You're the human, right? And so far, we still need us humans to make these decisions. Maybe within our lifetimes. Maybe my kids' lifetimes, I'm not sure. We won't need us humans anymore to make these decisions. But right now, we still need us humans to make these decisions. So this is one of the ways that we do it, is to pull information. And it seems simple, right? How can we connect answering these big complex questions back to parsing text? But it really just gets down to that, right? It's pulling order from chaos. That's what we're doing. ASCII text is like the lowest form of data. If we can get it to that format, we can apply these rules across everything. And in reality, like I say here, the concepts we learn here and the process is applicable across many, many different applications. Again, they're all kind of designed to search text. All these ones they name here are. But in reality, what we're doing really is a way to talk to a computer to get it to define rules that give us information to pull a certain pattern of text out of chaos, right? So that's what we're doing. We're learning the language that will tell the computer to do what we want it to do. Okay, a regular expression, you'll see this term, you'll see capital RE or regex, that's a common one. There's websites like regex.info, regularexpression101.com, that'll teach you all of this stuff, but you'll see regex a lot. It's not the data itself, not at all, right? It's representing a pattern that you apply to data. So it represents the data that you want. Right? Why is this like a big bad boogie thing that people always talk about, right? Well, they can be pretty complex. That's a valid regular expression. But just so you're not completely freaked out on what we're doing. You know what else is a valid regular expression? A period, dot. That's a valid regular expression. So don't get too confused by this, but that is a valid regular expression. And the challenge we have is a challenge that we've always had, that we've had in computers for a long time, in that our primary input for computers right now is this keyboard, right? There's only so many keys on this keyboard. I've seen movies where they show like Chinese keyboards that have like this many keys. Well, we speak English, so this is it. This is my keyboard. And this is not the totality of inputs that I can give, to a computer, right? I mean, we have, sorry, we have the ASCII table, which is this big. We have the Unicode table, which is this big, right? Which shows all these character representations that are not represented by keys on this keyboard. That's fine, right? I mean, the poop emoji, I don't have a poop emoji key. That'll be the new thing, right? Some computer come up with that's a dedicated key for the poop emoji. But when people created the regular expression language, if you want to call it that, I hesitate to call it language, representation, they pretty much just used the keys that we had on this keyboard. So, thanks, John. I don't have that many, right? And it's pretty much H or Z, and then a bunch of punctuation, right? And then some weird ones like percent and caret and ampersand and star, okay? So in general, that's kind of what we're limited to right now. And when we're talking to this regular expression engine to say, hey, I'm going to give you a description of the data that I want you to pull out. And ideally, in an ideal world, I would talk to the computer and I would say, okay, I want this and this and this, but not this and not this and not this, and only some of this and part of this. But we're not quite there yet. So I have to learn this language, thank you, to be able to actually represent what I want to get at this. That's where regular expressions come into play, okay? So why are they complex? Because of this, we're overloading common keyboard characters. So rather than passing them as data, we're passing them as instruction sets, okay? The dot is an example. I said that was a valid, this is a valid regular expression right here. And we'll explain what this is in a minute. That is literally like the simplest regular, that's it. Well, if I just write that on the board and I ask you all what it is, you're going to say, well, it's a period, right? What could all this mean? This can mean the end of a sentence, okay? That's kind of it. That's kind of what we use a period for. If I put multiple ones, it could be like it could be all kinds of things, right? But we kind of know what this is when it represents data. But in the case of regular expressions, it's not representing data. It's a command or control function, okay? A lot of the networks that we have right now are, here's an example. A lot of networks we have right now are SDN-based, software-defined networking, okay? So you've got a control system that dictates to all the switches, routers, what they do. So your network is actually broken into two planes. You have a control plane and a data plane network. Regular expressions are kind of the same way. We've got the data that we are parsing and that we're getting back. But the control, which is the commands that we're giving to get the data, it looks a lot like the data. This looks like data. It kind of looks like garbage, but it's all the same characters that are in my data, right? And this is where it gets confusing. Is because you look at this and you go, oh, God, is that a regular expression? Is that data? Sometimes it's hard to tell because we're overloading the characters. And this is where you kind of have to shift your brain underneath here. You have to say, okay, I'm going to use the characters themselves to define the data that I want to pull out of this chaos. That's why it gets confusing. We're overloading common keyboard characters. And then when we do that, we refer to them as a meta character. This is no longer a period. This is a representation of a data pattern that I want to pull out of a giant pool of chaos over here. Okay? The way to think of this is you have to understand how your parser sees the meta characters. This is another confusing one because, again, we're not talking to the computer. There's a layer of interpretation in between. And since this is a Linux users group, what is the layer of interpretation in between? Well, the first one is bash. It's our shell, right? When you type a command into bash and enter, the first thing that happens is the bash parser reads through what you just sent. And it basically looks for syntax errors. It goes, does this guy speak in my language or not? If the answer is no, it just says, try again, right? Or it'll say like, uncommented this, or it'll give some weird cryptic error, right? You may learn what that means. So that's the first barrier we have to get to. We have interpreters that we get to, right? I'm going to type something. Bash has to take a first swing at it. Then the second swing is the actual regular expression parser. Now this is important, and we'll see examples of this when we actually start typing this stuff for a couple of reasons. One is because Bash also has the concept of special characters. And there are some situations where you need to pass data to Bash that isn't actually data, it's a control character. So you have to tell it sometimes, hey, please treat this one normally. Don't interpret this as a special character. Pass it on to the next guy down the line. He's going to interpret it as a special character. And the second one is Bash has some special stuff built into it, specifically to do what's called file blocking. Now, you may not have heard that term, but we've all done it. We learned how to do it when we were children. Most of us by the age in this room, maybe not you. We learned dir space star.txt on prompt says list all the text files in this directory, right? And so it's it's really, really tempting to look at something like this and say, oh, look, I know regular expressions. This means anything, and then a dot, and then a text file. No! If you take nothing away from this talk tonight, if you forget everything else I said, remember, file blobbing and regular expressions are opposite ends of the spectrum. They both are trying to accomplish the same thing, in that they're using characters we normally use for data, my keys on the keyboard, as control characters to try to get a command across to an interpreter. What does this mean to the command interpreter? Match any file that ends in .txt, right? We know that's file blobbing. And it's like, it's been so ingrained in our heads for so long. That's, I mean, anybody looks at that, they really know what it is. Anybody works on IT, they know what it is, right? This means something completely different as a regular expression. In fact, this as is isn't even a valid regular expression, and why. But this bites people all the time. I have given this presentation, I have taught regular expressions so many times over the years. And I used to have a standard shell script that I would pull up. That actually was a production shell script that I wrote. It's weird to say production shell script, but there was an actual production shell script that had been running for years as a cron job in parsing data, a long time ago. And like the 9th time I taught this class, we were going through it, and I found an error.
Wasn't one of the classmates that said, wait a minute?
Yes.
I was there.
I was like, son of a bitch. And you know what it was? It was this. It was because I had confused file blobbing with regular expression matching, and I hung my head in shame.
Now,
Terrible.
the part of that, though, was you never ran across the condition where it would error out on that.
That's true. It actually made, what it did is it made the regular expression too greedy. I wanted it to match this, and it was instead matching this, but I never actually ran into a real life scenario where the data matched this. So I was safe. But it was still legit. And it's so easy to fall into that because we're so ingrained into knowing what this means. And it doesn't mean that when you talk about it.
That was a group from First National, if I remember.
Probably. It's one of my many
Mike Cousins
scripts.
Yeah.
Okay, so let's start. Let's talk about actual regular expressions. Now, my very first slide said this is the basics of regular expressions. Regular expressions, they're complicated. We're going to talk about the basics today. We're going to cover kind of the main 3 parts. We're going to get down to really all I've ever done with regular expressions, all the years I've done this. There is more that you can do. I've never kind of dived into it, to be honest. So we're covering what I imagine you'll probably do the majority of the time. But it's not 100%. Okay? So we're going to start with the 3 parts of regular expression. So we're going to start with the first one called a position anchor. Okay? So our first 2 introductions to regular expressions are these 2 characters, the caret and the $sign, and they represent those things. Caret means the beginning of the line, $sign means the end of the line. I'm going to do my best here to bounce back and forth with examples. Let's make this a little bit bigger for less blind folks. Is that better? Okay. So I am, what is this? Okay, this is not the latest Ubuntu, but this is Ubuntu. This is the directory user share dict. This is the home of dictionaries. We do a directory.
Could make it a little bit bigger.
A little bigger?
A lot bigger for internet people.
Oh, good call. There you go. How's that? Okay, that's better. So the Linux file system hierarchy standard dictates that you should have a directory on your Linux distribution, no matter what distribution it is, called user share dict. It should hold dictionaries based on what your language is. Unless you went crazy on the install and installed like Korean or all of your languages, you'll probably have one file. In this case, it's actually called, it's kind of weird. The symbols here are kind of weird. Notice that I have a file called words, which is a symlink to Etsy Dictionaries Common Words. Ooh, that must be the file we want, right? Let's look at Etsy Dictionaries-Common. Oh, look at that, words is a symlink back to user share dict web 2. All right, fine, I guess we're using web 2. And I can see by the size of that file, that's probably the one we want. Okay. So this is a standard, I have no clue why it's called F2. I really don't. But this is a standard dictionary file that you'll find in most English systems. Now, this is not like the Merriam-Webster dictionary. Okay, this is going to have stuff in it you wouldn't find in there. This is used for a lot of different reasons. It's used as a spelling database, for one thing, like commands like I spell. It's used as a seed for a lot of kind of random stuff. And it's just a good kind of example of words that are in your language. It's also some, you know, you'll see some capitals in here, you'll see some proper nouns as well. So don't think it's like the English dictionary. For our purposes, it's a really good example of testing our regular expressions. Okay, so if I just do a more out, you can see how it starts, capital A, lowercase a, all right? So let's do an example of each one of these to kind of get a feel for this. And again, remember I said that regular expressions are interpreted by, the regular expression parser engine is incorporated into lots of different applications. The easiest example that we're going to do is the program called grep. Okay? It's kind of one of the first commands that you learn on the Unix system. Did you all know that grep is actually an acronym? It actually stands for 4 words. What are the 4 words that grep stands for? Remember?
I don't know.
Does anybody know what grep stands for?
It used to. Global Regular Expression and Print.
And it's actually mapped against the syntax for the sed command. You guys know the sed command, the stream editor, right? Pass a bunch of text, pipe it to sed, do a bunch of weird stuff with sed, pipe it to another command, right? So the syntax, if you pass arguments to sed, actually looks like this. That's where the command grep came from. That's literally GREP is where they came from. That's, if you read them, like, I don't know if it's in the man page of sed, but I read some. That's the syntax for sed, and it's actually slash it in. So that's where grep came from. Grep has kind of become synonymous with the word search, right? I'm gonna grep, it's a verb. I'm gonna grep this file for this syntax.
It's a nice corollary to grok.
Yes, exactly. I was just thinking that too. Do you grok this? Yes. So the first one we learned, position anchors mean caret begin line. Well, let's take a step back here at first. Let's look at the simplest regular expression we can come up with. And we're going to use grep. Now this is GNU grep, so this is for the Free Software Foundations tool. And it's a pretty standard option for any GNU tool that gives output. You can pass it this option, -- color, which will colorize the output, which is helpful in this expression. So I'm going to do something like this. And we'll see what happens. So my command, remember, was grep -- color A in Web2. Okay? And what do we get? Well, grep is a line-based search command. That's important to remember because you are going to come across situations in your life as a Linux admin where you are grepping things that are not line-based. Please remember that grep is a line-based search tool. The best example I can think of where people are really tempted to use grep to parse data that is not line-based is HTML. Do not use grep to parse HTML. That way lies madness. HTML is line-based, right? It's just not. XML would be another example, but XML has its own weird crap we don't care about. Don't parse HTML. The problem is it'll work 99% of the time, but that 1% of the time it'll fail so spectacularly you'll never be able to recover. Okay, so this gives us a good example of how grep works. What you're asking grep is, show me every line that matches this regular expression in this file. And if you don't give it a file, it expects data from standard, but we gave it a file, okay? Show me every line that matches this regular expression, which is the letter A, lowercase a, in this file, okay? And then colorize the output. And there we go, we got colorized output. And this is useful because it actually shows what grep is doing. Why did Zymax.line Zymax match? Because it has an A in it. That's it, right? Pretty simple. We can do other examples. A, B, C. There are 3 lines in that file that match A and B and C in that order all next to each other, and they're colorized. Okay? The simplest example of regular expression, a character matches itself. A equals A. Okay? But we also learned that our first category of regular expressions, other than just the characters themselves, is a position. Caret means beginning of a line, $ means end. So I can do something like this. Caret
A.
What will this do?
We're starting with
Show me every line, not just words, right? Because it's lines.
A. Right.
One line could be soft, what you, through yonder window breaks, right? Could be lots of words. Every line that starts with lowercase a, and that's important, lowercase a. And there you go. There's every line in the file that starts with lowercase a. What does this mean? Go back to our slides. Every line in the file that ends with lowercase a. There it is. Easy peasy, right? How about this? What's that mean?
The only thing in that line is lowercase letter.
The line has to start with A and end with A. Will this match a line that has two lowercase a's next to each other? AA?
No.
No?
No.
How about 3 a's?
No.
4 a's?
No.
10 a's?
No.
A million a's? A million what a's? No, just one. Starts with A and ends with A.
But there's no AA in your file, so that's not really definitive.
If I did the search right, I would know the answer to this.
Oh, there is.
There's
What word is that?
It's not a word. This is why this isn't really a dictionary file. It's not a word. It's a bunch of words and then some other random lines like this.
Because
Why is that
dictionary
in there?
files are usually used for testing passwords and other
Yeah.
things.
Why is it in there? I don't really know.
So why didn't the 1A find both? Why didn't that find the A?
Right, because of the definition of these anchors. The caret says A has to start at the beginning of the line, and the dollar sign says end of the line. So think about the parser. It's going to parse that line. It's going to say beginning of the line has to be an A, and then the next character has to be end of line. That's a dollar sign. So it can only stomach one A. That's it. This will make more sense when we get into modifiers in a second. Just bear with me. Okay? So that's position anchors. Beginning line, end of line. There are others. I don't go into them here. This is why I call this the basics. There's actually indicators for end of word, beginning of word, end of paragraph, end of paragraph. I'm not talking about those. Okay? It gets a little confusing. This is just the basics. In my entire life, I've never actually used the end of word or beginning of word ones, ever. So that's something I worry about. Okay? So that's the first part, position anchors. Okay? Second part, characters and character sets. We already saw one character. It is A. It matches itself. All characters match themselves, right? I can say grep A in Web 2 would work. There's also special characters, or remember meta characters. That's the term we use, meta characters. Characters that look like data, but the regular expression parser built into grep treats them as a command. The first one is the dot. The definition of the dot. It matches any single character. So it's kind of like a wild card, but just be careful in using that file-bobbing thinking because it's going to poison your regular expression right now. It matches a single character. Let's try that. So let's go back to the simplest, this. What is this going to do?
It's going to match a character on every line.
A character on every line, right? Well, guess what? Every line is full of characters, but everything's red. What line wouldn't that match?
A blank line.
Be more specific.
Let's add a character.
Empty string.
And
A line that just had a new line or a character.
no white space.
Right. If it was just, how about if it was a space and a character?
Now,
It would match.
okay, now I'm going back to the AA that we were
Okay.
talking about
Yep.
before.
Yep.
In this command that you just did, you just cleared it off.
I'm sorry, I'll bring it back.
Every character is colored,
Yeah,
which
Every character.
implies,
There was 1, 2, 3, 4, 5, 6,
Every character
7,
matches.
8, 9, 10.
but
Matches.
the regular expression
Mhm.
only matches one character.
But
So
remember,
really, so in
You're
some
right.
sense, only one of those characters should be colored.
No, it did it 10 times on that line.
I see where you're going. Remember that grep, the goal of grep, match, or show me a line that matches this regular expression. This regular expression just says any character. It doesn't say where in the line this should match, because we haven't put the anchor in there yet.
Right.
Therefore, it's matching all of them.
And they're all getting highlighted.
Any single one of these would fulfill the request of this regular expression. And let's just pick a line, a nada, whatever that means. A matches, N matches, A matches, D matches, E matches, M matches. Any one of those singly would match them.
Singly match, yeah, yeah.
So it says all of them, they all match. That's why. Now, let's throw an anchor in there.
Yeah, you're only the first day is gonna be colored.
There you go.
Yeah,
That's,
but, yeah.
okay, so we get the same result, but it's only colored, the first character will be colored. What is this going to do?
The last one.
Whoops, that one. What's that going to do?
Only if it has a character.
What's that done?
What character line?
Yeah, like A, B, C, D, yeah, each one, yeah, one character line.
Only one character.
I-
Right. There you go.
Oh, caps too.
Caps too, right? What if, now we don't have any examples in here, but what if in this file, there was a line that just had a percent sign on it? Would that match? Yep. Any character, except new lines. That's a special, right? Any character. There just aren't any in this file. Okay? What would
Does
this
that
do?
also include non-printable characters?
Yes, thank you.
See, I was about to go there too.
Also non-printable characters, right? Control characters. The tab is matched by the dot. Yes. What's this going to do?
It has to have.
AA will be one of them.
Two characters.
And only 2 characters.
And only
Yeah.
2 characters. What's this going to do? Sorry.
Oh no, this big ball.
Lord, really? This is, I'm asking too much of you. You have to run back.
You have a virus
What's that going to do?
that's going to show, basically the same thing as the single type. No, it has to have 2. It won't show single characters. It'll show 2 characters. And so you're going to have some
2
of
or
those
more.
lines show up with black,
2 or more.
2 or more,
with black.
right?
But no
So you're
single.
going to have some black areas.
And only the first 2 will be colored.
2 or more, right? Well, we read right to left, left to right English, so it's going to be 2 or more. Is this going to show just the letter A all by itself on a line?
No.
No, it didn't, right?
It's going to be 2.
Because I said, oh my God, I said 2. And anchored at the beginning of the line. Anchor, 2 characters.
What do you got your history set to, like 10,000 lines?
Dude, it's not the history, it's this Mac, it needs to go away. I promise, it's, plus I have 94 Chrome tabs open. I'm not closing them because it took me forever to cultivate all of them. All right,
History.
let's go back to the video. Okay, so characters in single character, anything, okay? Okay, so this is our first introduction of a character set. A bracket, the left bracket and the right bracket indicate a character set. Think of this as an OR command. Let's just do this by itself. What does this mean?
Anything that has an A, a B, or a C in it.
In what location?
Doesn't matter.
Any location. We took away our position anchors, right? So it doesn't matter. Anywhere in A, anywhere B, anywhere or C. Any of those work. Even multiple, right? This has a C and a C and an A. Great. Easy. What would this do?
Only if it started with an A, or a B, or a C.
Bingo. ABC. What if, I'm going to break out of mode for a second. And I'm gonna make-
That's a great one.
I'm going to make a test file. A, B, C, A, B, C, A, B, C. There's your test file. Okay.
bash pictures up here. While my typing, tell me what this, oh, for real? Thank you. How many lines will this return?
Two.
Return 2. Okay. How many lines will this return?
All of them. 1, 2, 3, 4, 5.
What if I only want to return the last line?
Then you do tail.
Then what? I do no next one, and I'm done. I like the way you think. That is absolutely an acceptable answer. Not what I was going for, but an acceptable answer.
Oh.
How do I craft a regular expression that will only return?
You need an escape character.
I need an escape, right? So this is a situation where my data contains a meta character. My meta characters in this case are grep. Grep knows those as control characters, meta characters, whatever you call them. Instruction is not data. I have to tell it, no. Please, for this one instance, treat them like data. And the way I do that is I have to escape them. That's called escaping. The left or the backslash escapes a meta character, so it's treated like data.
There goes the beginning of what makes grandpa. Oh, that didn't work.
Because you didn't clarify them.
Why didn't that work?
It's still a weird thing.
Didn't work as expected.
Oh,
Yeah.
that's the-
Why didn't that work?
Because Bash extracted the backslashes.
Because frickin' Bash trying to outsmart me.
Separate from single ticks.
So this is a tough one. This is where you have to remember what parsing is going on behind the scenes, right? We're actually 2 levels away from giving our desires to the computer. Bash is the first level, grep is the second level. We have to think how the parser thinks. Bash is the first one that gets a stab at this parser. And you're right, it is going to attempt to honor those escapes. And so it just goes, oh, you don't need to escape those records, it's fine. I'm just going to drop these. You'll thank me later. So there's a couple ways to overcome this. And I like, this is fun because I'm not 100% sure if this is going to work, but we're going to try.
You do.
I love live demos. Let's try this.
No, I really mean.
No, I know, we'll get there.
Yeah.
Let's- Yeah, I know.
That's what that means.
This is something Bash do this. Leave my shit alone. I'm literally escaping the escape.
Because it's passing it down.
This hurts my brain.
Single tick should work.
There is a better way to do this, yes, thank you. And this should work. Ha, I didn't test this, let's see. This is kind of a tried and true way to tell Bash, get your dirty paws off my data. Just leave it alone. I know what I'm doing. You just pass this data on to the next. Don't try to parse it. That's a single tick. You'll see this when you're doing Bash, and this can bite you in Bash because in so many cases, the single tick is synonymous, the single quote is synonymous with the double quote. They work the same, except you have to remember that a single quote for Bash means leave the data inside there alone. Don't try to parse it. Double quote means it's very mean. You usually run into that with variables, like I go shell, right? It parsed that variable and it replaced it with bin bash because that's my shell. What's this going to do?
Literally put
The same thing.
Oh,
What's this going to do?
What the dollar share.
There you go. There's your difference. That's the difference between single quote and double quote in bash. It will save you a lot of headaches if you remember that. Yes, so back to our regex. This is a much cleaner way of writing this. Now, do you have to do this madness if you're doing this in Perl or PHP or Python or C? No. We have to do this because we're dealing with bash. Okay, this actually isn't part of the regex. This is tricking our interpreter into allowing us to pass a regular expression through it.
Well, if you said to grab a file of your regular expressions, you wouldn't have to do it either.
Oh, that's true. If I stored my regexes in a file and then glean those from the file. Sure. Yep. Sure.
Or can you cap the file and pass it in there?
I wouldn't make any difference. We can try it. It shouldn't make any difference though. Because we're still fighting the bash interpreter, right? That hasn't changed. We've just changed how we give bash the data. But still, it's still the same order of operations, right? Similar. Okay. So keep that in mind. And the tricky thing about this is, and you're gonna run into this doing regular expressions, you're gonna craft this beautiful regular expression that's gonna work. But then 6 months later, you're gonna realize that, oh, it's actually matching this much data when you only wanted it to match this much data. That's called a too greedy regular expression. So be careful with these because they can trick you. Okay, so to review, we talked position anchors, we just talked about caret and dollar sign, okay. Then we started characters and character sets. We have the dot so far that matches any single character. We have the character itself, A matches A, B matches B. We have sets, matches A or B or C. Then we have ranges. This is really just a modified set. Or you can kind of call it shorthand for a set. The regular expression parser is smart enough to understand ranges, when they're obvious, like A to Z or 0 through 9, 0-9. It'll do that. It'll work. Okay, and again, remember this, case sensitive. You always have a choice when you're crafting regular expressions. You can either make your regex, let's say I want to match all letters. You either have to make your regular expression itself match all letters, so be case insensitive, or you have to tell the program or interpreter or brain, whatever you want to call it, you have to tell it, please be case insensitive. So here's an example. We did this already, right? A in Web 2. Well, here, let's make this a little easier. Ha, my bad. Okay, match to 1, right? How about if I do this? What's that gonna match?
Upper or
Right. So the beginning of the line has to start with lowercase a or capital A and then immediately end. I should hopefully get 2 lines. If those lines actually exist in the file, which they do. How about this? Dash I tells graph itself, please be case insensitive. This can be a little confusing because now our commands are coming from 2 locations. They're coming from our regex itself, and they're coming from an option we're passing to our interpreter. It's up to you how you want to write it. It's up to you. I was going to say I have a preference, but I don't really have gone back and forth with you.
So right, think of it this time.
Yeah, whatever you come across at the time.
So it also would depend on how portable you want it to be as well, where it's going to go.
Absolutely, right? If I want to be able to copy and paste this into Python or I don't know, some Perl or the Apache
rewrite.
What's that called? The rewrite rules. The Apache rewrite rules have the regular expression engine built into them. You can create regexes that match rewrite URLs and rewrite them. I've done it. But yes, you're right. If I'm just copying and pasting this, and this one is not case insensitive because I relied on the dash I to grab it, I might run into problems. So just something you have to keep in mind. Okay, so we did single, we did sets, we did ranges. I'm going to give an example, but you see what works. Okay. All right. Let's start getting weird here. Right. We already saw caret once.
It just throws me.
This is a different use of caret. Because remember, it's all back to you got to look at your keyboard, and you got to say, not only is this all of the data options I can give, but this is all the control options I can give to.
It should have been exclamation point.
Right.
We're all thinking.
Or I should have been able to like hold out another keyboard for my command sequences, right? But so we overload these. So it's a lot of what does this character do? Well,
at this point,
it depends, right? And so inside a set, this means negation. It probably should have been an exclamation point, because every other language does exclamation point as negation, but not regular expressions.
Well, the caret was negation before regular expressions.
was it?
It was?
In mathematics.
Oh,
Oh,
there you go.
In logic.
I didn't know
The
that.
other language is wrong.
I didn't. Everything else is wrong. Math wins the day. Okay, first, hold on.
So maybe we should have used exclamation point as the line start.
Let's go back in time. Okay, so let's try this. What's this gonna do? Show me every line. I gotta think about this one.
Uppercase A or uppercase B?
No, I took the dash I off. Oh, I see, okay.
Yeah.
Show me every line that doesn't contain A or B or C, right?
No,
No?
no.
Start. No, there's no start.
There's no start. The carrot is not, the carrot is not a positional here. It's not a positional.
Doesn't contain lowercase a, b, or c.
So show me every line that does not contain lowercase a, or lowercase b, or lowercase c.
I agree.
Oh, they didn't.
Well, but we didn't tell where.
Oh, okay, good point.
You're not
We didn't
selecting.
tell where.
Oh, okay.
Our red text is too greedy. Too greedy. Because I said, show me every line that doesn't, but really we're saying color every character that doesn't. So if we want to make this, okay, let's think about that. Show me every line that does not contain A or B or C anywhere. How do we do that? No possessionals.
What's fine?
No, because that'd be
Put
how
plus
many?
after,
Yeah, but that's zero.
none or more,
That's zero.
one or more.
Just using this negation, can I do this with just this negation? Because it's going to match everything else that doesn't match that. But grep is a line-based match, not a character-based match. I don't know if I can do that with just negation. Show me every line that doesn't. Yeah, see if that was my task, show me every line that doesn't match this, I would probably cheat and use I think it's the dash O option.
V for
Oh,
lowercase b for omit.
The V.
V
thank
is
you.
invert,
The V from, that's what.
the O is only.
Right, I mix those two up. So if you give grep the dash V option, it inverts your search. Only show me lines that don't match everything I just want. That's cheating because it only works with grep, right? But it would get me my end result.
But with grep, you can do
Does it work?
dash E and dash E. You can do multiple expressions.
Right,
For feeding
but I shouldn't have to
together.
do that.
History files.
I swear it's not it, dude.
I do.
It's the memory on this laptop. I'm not even logged into this laptop. I'm logged into my server at home. I'm not using Bash on this laptop. It's just SSH master server.
Yeah, he's remote.
No.
2,000 lines.
That's a good year.
It's not that big. Anywho,
It was the year before the child came.
okay. So well, let's keep going. That's negation inside of a set. The next thing is named character sets. This is not necessary. You do not need to do this. This is only here as a shortcut to you, so you don't have to type as much. Look at my last line here. So the character set, bracket, colon, alpha, colon, bracket, is equivalent to typing out A through Z, or maybe A dash Z. That'd probably be a lot faster, right?
Well, but it's upper and lowercase, so you only represented lowercase there.
All right, let's try that. You're probably right. Let's try that.
2 brackets.
I know, I'll make a point of that.
Yep, caps are in there.
You're right, capture match, you're right. I need to update this line. Okay, the thing that always gets me on these is that it's very, very tempting to do this.
Yep.
And what does this mean? This is a character set. This says match every line that contains
Okay.
a colon or an A or an L or a P or an H or an A or a colon. Oh, wow, that's awesome.
Yeah.
Perhaps even smart enough, you jerk, you probably did this. That's awesome.
Somebody got burnt.
Somebody got burnt. Screw you, bro. Oh, you're right, I did need double right.
So you can't use that as a graph, as a.
You'd have to put,
You have to
quotes, you'd have to escape it somehow.
To grep is.
That's a good question.
You'd have to.
What is grep looking at to determine that? Maybe I actually want that. No, I'd actually write it like this, right? I don't need the extra A or the extra colon.
Yeah.
There it worked. Maybe it's looking for the colon beginning and end. I swear I've never run into that error. That's fantastic.
Ones, if you wanna do a range one like A to Z and a hyphen.
Oh, okay, so like this? Like that?
Yeah.
Okay, so what is this? That's good. What does this match?
I think that's valid there. I think that will do A to Z and a hyphen.
And then the hyphen character. Yeah, you're right, it will. That's super confusing because that's a double use of the hyphen. We're overloading the hyphen there, right? Hyphen is indicating the range, but then by itself, it matches itself. Yeah, that's a good one. So I do use these, but I swear I have done this wrong more times than not right. You have to remember that it's inside the character brackets, the thing itself has brackets around it again. And I give some examples there. Alpha, alnum, digit. There's one called printable, match any printable character. Alnum is pretty useful because that's all letters and numbers. There's one called punced, P-U-N-C-T, match all punctuation.
Not alphanumeric,
That's
all
useful.
letters and numbers.
Oh, that's all num. A-L-N-U-M, yeah.
I hadn't heard it said that way before. That was
Yeah,
kind of fun.
alnum. So that's pretty handy. Okay. All right, so that's characters here. That's the magic there is the bracket around there, or the dot, which is a single character. Okay, that's parts 1 and 2 of regular expression. There's one more we're going to talk about is a modifier. This is where we start talking about the differences between this and file globbing, because the very first modifier we talk about is the splat, or the asterisk, or the star, or whatever you want to call it. Asterisk, right? We know this. It's like in our bones. We know what this means, right? This doesn't work in a regular expression because the definition of a modifier, look what I have listed in parentheses there. This is important. It modifies the character or the set immediately to the left. A modifier character by itself or with nothing to its left is meaningless. Modifiers are not regular expressions by itself. That's why this is meaningless as a regular expression, because the star is a modifier. What's it modifying? The thing immediately to its left. What's immediately to the left here? Nothing. This is not a valid regular expression because of that. Okay, so easy, right? We're done. Here's what bites us though. We look at this, and in our DOS trained brains, what does that mean? TXT star.
In globbing or in regular expression?
Well, that's the question, right?
He said our DOS brains.
Our DOS brains so globbing. We immediately look at that and go, oh, any file that has TXT and then ends in whatever, right? Not if it's a regular expression. What does this mean as a regular expression?
TX and then T or more.
Oh,
Any number of T's.
Any number of T's.
Yep. Show me every line that has a T and then an X and then 0 or more T's.
Yeah.
That's what this means. That's what this means. That's kind of non-intuitive, right? Because we look at that and we think we know what it means. T, I have no idea what it means. I got one. Give me every line that has a T and then an X and then 0 or more T's.
So that's a perfect example because you don't have the T.
Because I don't have a T. It matched because it's 0 or more. What's the plus sign mean?
One or more.
So how many lines is this going to return?
None.
0.
1 or more T. Question mark means exactly 0 or 1. This doesn't get used as often.
How come that didn't work?
Why didn't that work? Oh,
Because it's bash.
There's no TXT in the file.
Escape the.
hold on. Oh yeah, there we go. Okay.
Oh, it's standing grep.
I forget what I did. What command have I been running? Grep. Right? Let's read the man picture and grep. Look at the very top line under name. What does it say? holy crap, there's 4 commands there. grep, egrep, fgrep, and rgrep.
This is because it's just shortcuts.
When all else fails, read the instructions. In addition, the variant programs, egrep, fgrep, and rgrep are the same as grep-E, grep-F, and grep-R. What does grep-E mean? Very top line. Extended regular expressions. Okay. So you guys all probably know this by now. I've been doing this for a while, right? Every time I give a talk, I have to have a little bit of history lesson. This one requires a little bit of history lesson. Way back in the day. Way back in the day, when memory on computers was short, there was a regular expression parsing library, and there was an extended regular expression parsing library. Exactly. And when computers were short on RAM, it actually made sense to not always bring this whole guy into memory to put to bear on a normal regular expression problem. Most of the time, the simple regular expression parser was good enough. But then you started getting complicated, and you had to bring this other engine into bear. And it was such a memory hog that it was decided to split it into 2, and it was up to us as the admins to determine when it was okay to bring this other one into memory. This has not been a problem for 40 years. But here we are. Still 39 and a half years. grep by default will use, I don't know what it's called, the basic regular expression engine, the simple, whatever. It doesn't use the extended regular expression rule set by default, unless you run grep with the -E option, or, as we learned from the man page, egrep.
It's deprecated.
Did you see
Who says it's deprecated?
That man page.
Seriously?
Yeah.
Why?
You're supposed to give options to your grep command.
Oh, bullshit. I'm gonna run
Until they take it away.
I'm gonna continue running egrep until they cry for
So
me.
you're gonna run that step.
I'm also running NSLOOKUP and NSStats until I die. And if you think, until I die.
You learned the netstat tuna last month.
So, and we can see the example. This gives us nothing. This, if I can figure out how to use bash.
And what does that mean in a Perl regular expression?
There is a modifier for grep, the
I didn't see
-P.
How are
That's
Perl regular
experimental.
expressions different from regular expressions? No idea. Sorry, I have to leave that as an exercise to the listener. I don't know.
It probably is a lot of UTF-8 or 16 and all that.
Perl is,
character
I know
set
this one.
stuff. I used to know a lot more than I do.
So, just use egrep for the rest of your life. Just type egrep. Honest to God, just do it.
You're just alias the command.
So,
No,
or just alias is correct.
Well, with
Alias
dash
egrep.
color.
They'll be happier. We don't have to worry. It's like 2K of memory is what we're talking about. It's ridiculous.
DI really is them.
Yes, yes. I typed it in and it didn't work. What? Oh my God, I have to insult. Yes, so this will bite you because you'll think, my God, I didn't write the regular expression correctly. No, make sure that you're using the extended regular expression. And this is where it cuts off. This is the confusing part. Is it cuts off at like kind of a random place. It understands the position characters, right? It did that. It understands the character sets. It understands the star and the plus. But for whatever reason, the line is drawn at that question mark. Who decided that was where to draw the line?
It was a question mark.
Because most people went,
Yeah. Oh, that takes an extra K of memory. Done. Okay, so that's why.
Grammar school.
I guess. Gotta spin in the background. Okay. Two more modifiers. We introduced the brace. This is a little weird because this kind of looks like a set, right? In that it's an or. But remember, these are modifiers. These are not characters themselves. Every one of these, every time you type one of these, it's modifying the thing immediately to its left. That's it. It has no definition by itself. Never will. It's always modifying the thing to its left. So this means match a set from 1 to 5. Why wasn't a dash used in there? Why didn't we use the same character in the, because that would make too much sense.
is it maybe another math related?
If I figured it out, John, I wouldn't have that to complain about. It's my financial short. Don't take this from me. And finally, we have the pipe, which is or match.
And these are, braces.
How's that?
Brackets.
How's that a modifier? Wait a minute, how's that a modifier?
What?
Oh,
You
okay.
said 1 to 5 of the previous character.
Oh, wow, that one got a slide, I got a slide ahead of myself on that one. That should have been in the next slide. Because that's what I needed to
Yeah,
change.
and he's asking before this.
All right, so let's do this one.
Yeah.
So let's say this one first. So this is matching, so let's try it. Ooh.
Just put like A.
Whoa,
Just go with A. What?
it's,
It
You
could
gotta
be
escape
more
it,
than-
man.
There's Bash trying to be tricky again.
or either that or do a dash, if you do a dash E, does it still take it?
I think it would be the same.
Yeah, it would be-
The parser is still gonna, the Bash parser is gonna parse it.
E-grep just does grep best.
Yeah.
It's, yeah.
Hmm.
But there isn't any.
Yeah, the only word in there
Use
is the
letter
one on the
A.
other
Use the letter
complex.
A.
It doesn't have a.
TXT.
Oh, thank you. Yeah, that was legit. It returned nothing. Oh, there you go. I didn't put any anchors, right? So show me every line that has 1A, or 2A's, or 3A's, or 4A's, or 5A's. If I do this, give me this mini thing. Give me this mini thing. Come on. Do I have any that actually have more than 1A in?
AA,
Did that match?
that was right at the beginning.
There you go. Okay. So that, well, I don't like typing through more because it removes the color. But that worked. Show me every line that starts with an A and that has 1A.
Your color option can be color always, or if you do color equal always, it'll go through more too.
Really? So dash color
But then that'll
equals
screw you up if you try to print it.
like that.
Yes.
Today I learned I can do that. I did not know that. That's awesome.
Always done, and then there's something else that does the smart.
Oh, I love learning stuff. That's cool. I
And
didn't know
that'll
that.
screw you up if it goes to a printer.
More than an alias in your bash.
That's cool. Okay. So start with A and then give me either 1A or 2A or 3A or 4A or 5A. Any of those. Not 6. Actually, no, it would, because I don't anchor the end of the line, right? Let's test this. I'm gonna go back here. My file is called test. A.
Fonzie?
5, 6, 7. Yeah. Give me the rainbow. Taste the rainbow.
Looks like a Skittles.
Okay, so what I'm gonna do is I'm gonna test my, while we're waiting patiently, I'm gonna test that regex against my new test file. Specifically to see how many lines I can return. I'm gonna ask for, give me every line that starts with A and gives me either 1 or 2 or 3 or 4 or 5. That's what this does, right? My file's called test. Now, how many lines will this return?
Because they all have one.
There you go. I didn't anchor it on the end, right? Oh, because it's or 1 or 2 or 3 or 4. Well, how many will
But
this return?
Put 2 comma 5
Okay, let's try that one first.
or 3.
And then we'll anchor it. Let's do, yeah, 3. There you go. 3 or 4 or 5. Right? What will this do?
Only show the one that has
3, 4.
5 in it.
Not 6A or not 7? Right.
3, 4.
There's my inlining. And in general, my advice to you when you do regex is that that's a good habit to get into, is anchor them with caret and dollar. Define specifically what you want to see in the line. Or you'll end up with a greedy regex that may give you what you want initially, but then later on down the line, you'll get more than one.
And you might wind up using a lot of memory until it exits out of the big files.
That's, forget that last one, I shouldn't have thrown it into the monitors. So, in review, we did 3 parts of a regular direction sort. We did position anchors, caret and dollar sign. We did characters and character sets. Remember, this is the individual characters and then all this special stuff, brackets and named character sets. And the third one now is modifiers. Thing to remember here, that everything here represents itself, represents a single position, right? Modifiers don't. Modifiers only modify the thing immediately to their left. That's it. They have no inherent value on their own. Don't confuse them with file blocking. Okay, so now we're going to talk about parentheses.
And this all fits into the three categories we just talked about. Parentheses are used in three different ways. Grouping is the first one. So let's look at my question here on the slide. What is the difference between these two commands? Notice I'm using egrep. We're just using egrep from now on. Egrep. And I'm double quoting. It's not necessary here, but I've kind of gotten into the habit over the years of double quoting everything that I feed Bash, just so there's no question. Bash still gets to parse it, but it would actually work either way. This is just a habit of mine. Okay, what's the difference between those two commands? We're going to run
Looks
both.
like we're gonna begin.
But tell me what the difference is. Will they return the same results?
No,
Why not?
maybe, let's see.
Is there a space between that?
No spaces, the bad font. I should have,
Oh.
no spaces.
It looks like a space.
It does, you're right. It's a bad font choice.
Well, you don't have a or, so I'm really confused by the parentheses thing.
Okay, so what the parentheses mean is we're grouping this.
Okay, so.
So the
A, B
modifier,
are together.
the modifier will act on the group.
So A, B together, and then we gotta have it.
How many of them?
Twice.
Exactly two. Less than two? No.
No.
More than two? No.
So
Exactly.
it's gonna start with AB.
More than two.
Oh, why?
AB, because.
Because I didn't end it, I didn't end it with an anchor.
Yeah, you didn't.
So would AB match that first one?
Yeah.
Absolutely it would, okay. What is this one gonna do?
That has two.
A,
Starts with A, and then has two B's, and then whatever, we don't care.
Yeah.
Right? Very good, you guys are awful. Let's try it.
Sounds like the enterprise destruct code, 1B, 2B.
Up, down, left, right.
It's like diffusing a.
Color equals.
The green one.
Now that would be awesome.
We'll
Diffuse a
do
bomb,
those.
get to solve this regular expression.
AB
We're
2, and web.
It's never the yellow
Did I get it
one.
right? AB2, okay. So again, this is gonna show us every line that starts with AB, and that's that in. I say we'll probably get nothing. This is where our dictionary file fails us.
you need some ABBBs.
And you do not?
You need some ABBBs. You're in here editing, you might as well do it now.
Good call.
ABBA.
So, I overloaded the input parser. Okay, so let's look at our file. And we're gonna run that first graph on.
You know, if you didn't use egrep, would it go faster?
Would this go faster? If I threw this against the wall, would it go faster? I feel a lot better. Okay. Color always, show me every line that starts with AB, and then I don't care. So we should get how many lines? 1, 2, 3, right? You got 3 lines?
Yes.
And the color, let me do it again here. The color shows us that what is matching. Take these out. What do I get? A, and then 2 B's, and then I don't care. And of course, if we want to be really specific, we can throw an anchor in there, and that's going to give me exactly
None.
Nothing.
squat. Yep. Good job, you guys. Okay. Grouping is the first way to use parentheses. The second reason for parentheses is the or. Now we saw ors already in character sets. If I just did left bracket ABC, right? So you say, what's the point of this then? If this means, show me every line that starts with A or B and then ends, couldn't I do the same thing with caret bracket AB bracket $?
Potentially, but this gives you more freedom if you want to use like your pluses and stars and.
True. Okay. The answer is yes, that would be the same thing. But I could do modifiers here. Also, that whole ABC thing in the character set, one character, A or B or C. This lets me do X number of characters on either side of the type. I should have probably changed my example to
Can
be
you
more than one
do
character.
A-C, or does it have to be A through Z?
Ooh, let's try. Let's see. So let's start simple first. Let's go start of the line. Actually, let's forget start of the line. Let's do this first. We said A or B. What's this going to show us? Show me every line that has the letter A.
A or B, anywhere in it.
Oh, I'm reading my test file, so that's probably good. It's a lot smaller. Okay, A or B. Easy enough. What's this going to do?
Gotta have a group of AA or BB.
No anchors, right? So anywhere in the line, any number of times in the line.
Yeah.
I mean, we can anchor it if we want. Let's try it.
This
will-
AA or BB.
That limits us a little bit, right? We anchored at the beginning. We could anchor at the end.
Would you be able to do A or B or C? Throw an extra one in there, or?
Many as you want.
Alright.
I mean, I suppose within bash buffer overflow, so I don't know what that is. Okay, so look at this one. Show me every line that starts with AA or BB. We only got one because it's an or. It matched the AA, that was fun. And then ends, sorry, and then ends. That was I need to end. So parentheses can be used to indicate or groups, and that group could be. So your question was, can I incorporate sets into this, right?
Well, I just, on that range one, I've only used A through Z kind of things. I don't know if I've done A through like F in the partial range.
What will this do? Oh, actually nothing, unless I do this. We're starting to get a little more complicated here. What will this do?
Anything that's lower or upper.
Right, start of the line, then a lowercase or an uppercase. I mean, this is a really complicated way to say give me everything at S and A to a Z in any case. And I just did my test file. Oh, only one letter though, right? Right, because I did the or. What if I want one or more?
Plus after the parentheses.
Right. So let's look at this one. So this is getting a little complicated now. This isn't just something that can be easily parsed. You got to kind of think like a regex parser now, right? You start from the left. Remember, the double quotes are just there for bash. I just do it to be safe. It's not part of the regex. It's just because we're passing it to bash. So forget the double quotes. Start with the caret. Caret means anchor to the beginning of the line. So show me every line that starts with, then immediately we see parentheses. So we're thinking, okay, this is grouped, right? So we have to kind of read through the parentheses. There's a pipe in there. Okay, so I've got two options. Let's parse the left option first. Oh, we got a bracket. That means it's a set. What's my set say? Lowercase a through lowercase c end set. We know that one. Easy. All lowercase letters. And then an or. And then, another set. There's a left bracket. Uppercase a through z. Okay, end bracket, done. Easy enough. Then the next character is what? That's a modifier, right? Modifiers have no inherent value on their own at all. They only affect the thing immediately to their left. Now, in this case, the immediate to the left is a group because it's in parentheses. This is where the power of the parentheses comes in when you combine it with the modifier. The modifier now is not just modifying this or this or this. It's modifying everything in this parentheses because we grouped that all into one section that the modifier then acts on. So remember, plus means one or more instances of that letter. A really complicated way of saying give me every word that has a lowercase or an uppercase word. There you go. So match everything. Except
the one with the bracket.
Except the one with the bracket, right? Because the bracket is not included in our set.
But you could add it when you get
Comma.
the beginning.
So let's look at our file first. You're right. Well, it missed two lines actually. It missed our blank line.
Yeah.
And it missed our line with brackets in it. How do we match the line with brackets? How do we add to this regex to match the line with brackets?
And put
Another
bracket
or.
in front of the first bracket.
Okay. We have a couple options. Let's do yours first.
Okay.
What was yours?
Put a bracket in front of the first bracket.
Okay, then what?
That's it.
That's it.
Oh, no, I need one at the end too.
Need one at the end?
Yeah, well, no.
So we're like doubling the set? Whoops.
I don't know. Or do I put it in the front with the other one?
How about
Let's put it in the front with the other one.
put it like that?
Yeah.
This is fun because I don't actually know the right answer. We're gonna have to try it and see.
That's in front of the hyphen.
Should we try and see?
Well, that's not gonna,
That's just gonna work.
You didn't put a dot between the two brackets there.
You might need an or conditioner in there as well.
Okay, because the brackets are indicating the start and ending of the set we're saying here
No.
is and on, right?
I gotta put the bracket, if I just want the one with the bracket, I put the bracket actually.
I want the output we got before. I also want the line that has bracket ABC and bracket. Welcome to Regexes. Will this work?
Oh shit, it worked.
Why did that work? I did not expect that to work.
it shouldn't work.
Ta-da, drop the mic.
It should. That's the best part of the part of programming, right? It should work. I'm really surprised it worked. I thought, okay, should be interpreted as a set. Maybe because we didn't put anything in the set, it's interpreting. I don't know.
Yeah, it's like.
I really thought I'd have to do something goofy like this, but I didn't.
Or a pipe.
Because you're-
Or right, I was gonna do something like that.
And I would have thought,
That's what.
yeah, or I would have thought that the.
I got the same result.
That the right
Okay,
bracket-
that at least makes sense.
Yeah.
Okay, so because I didn't put anything in the set, it's not interpreting it as a set. Let's test that
But it's still
hypothesis.
taking it as a character.
Let's
Yeah.
put this.
Oh, now you just ruined it.
Oh, there you go. That's exactly what happened. So
It's just looking for the two characters.
because I didn't put
Empty
anything
set
in the
is
set,
the character.
well, it must say, oh, you must not think this is a set.
But I
So I'm going to
was-
interpret it
that's
as
the
brackets.
beginning,
But you're looking for brackets.
Well, my line does have brackets at the beginning. Should I make a line that doesn't?
Yeah, do that, but,
Put some
move the
numbers in there while
brackets,
you're at it.
move the brackets after the second A to Z.
Like that? Well, what's the numbers?
No, I don't mean that, I meant in the expression itself, but
Okay,
that's fine.
so do what now? Well,
Well, go ahead and run your test.
wait for the rainbow.
I would snap my history.
I have to wait for
All the way.
Where is it going to get bash lookup?
Okay, so I
You have
added.
hot storage, you have warm storage, you have cold storage. I think this is the cold.
I'm waiting for it to take us down. That makes sense.
At least we don't have to wait for the operator to load the tape.
Try, take the left and right bracket out.
Yeah. And the pipe,
And
so-
more, yep. And put that at the, end, put it after the big A to Z. Keep going, right there.
But the pipe,
Try that. No,
just by itself?
Yep.
Why would that be?
that's what I'm saying. It has to be at the beginning. Just like a dash has to be at the beginning.
We have the dash at the end.
This one's breaking the rainbow. Why did that error
Could
out,
have made that work.
but the other one didn't?
It's gotta be at the beginning, I'm sure it has to be there.
Okay, this isn't a bash error, this is a grep error. So grep says, well, you passed me a bad regex.
Man page, I don't know, info.
Which it kind of does look like a bad regex, which I agree, but that doesn't explain why this
Let's put a pipe in
works.
there.
It's gotta be,
You're right, but why does this work?
it's at the beginning,
Why does that matter?
because man page said so.
I mean, clearly it does. I'm missing something here. I don't know why that's.
Something to do with the order of operation.
Because today is
Yeah,
Tuesday.
that's what kind of what it is.
I guess.
Well, if you put.
We are definitely, we're
If you-
into adamant.
if you put the double,
Yeah, let's go back,
If
yes.
you put the double brackets after the lowercase a to z before the pipe, it'll fail there also. We try to.
Let's try this.
Okay.
So A to Z or, capital A to Z or empty set, which I guess we proved is being treated as left and right bracket. No. What the heck? See, this makes sense to me. This makes sense to me that this would error out. Because this makes me think that maybe this will work. Well, no, wait,
There's
it
nothing
works.
in between.
It works because it's nothing in between. Let me do like a good scientist and fudge my data to match what I expect. Well,
Or in the count.
let's do one more. Oh, skill tax.
Did you say Skittle
This
tags?
is the skill tax, right? Okay. All
All right, so I'm gonna add a line that just has the open and close bracket. I'll take the bars. We're at a line that just has open and close brackets. We already did a line that has open and close brackets and garbage.
Which this should
Come on.
match.
Bastard. Okay. Okay. So there's our 2 lines. Let's try this again. Oh. Oh, that's right. It's the internet. We can't swear. God. Man, it did kill all my bashes. Oh,
Is that chocolate?
oh nice.
I ate all the Skittles, unfortunately.
That's not chocolate.
Oh, you're looking.
Snickers.
Close enough.
There we go. There we go.
It's number 10.
So show me every line that starts with A or Z, or capital A or Z, or left and right bracket, because I escaped them. And this is a fun one because I'm not escaping for bash. What am I escaping for? For grep. I had to tell grep, don't treat these as special. Don't treat them as meta characters. Treat them as data.
You're letting bash go.
You're not.
Add that because there's double quotes. You
I
said,
don't think that'll matter.
But
I mean, let's try.
That's in the process of empty set though.
yeah, it should be an empty set.
It's not coming in, it's the one with the bracket, ABC bracket isn't there, you take it out.
Oh, you're right.
It's not-
Well, that makes sense.
Yeah.
Well, no, it's, that one's not, this isn't being interpreted as empty, that's being interpreted as left bracket and then right bracket. I would have to say, escape,
Yes.
left bracket, dot, star, escape, right bracket. Show me anything that has a left and then anything and then a right bracket.
Left bracket, right bracket,
Yeah.
one more.
All right, what was I doing? Oh, there is double quotes. Let's try this. Oh, there you go. All right, so the double quotes was necessary in this case. Oh, why? Oh, sure. Because bash treats parentheses as special. Here again, you have to remember to think like your
But I
parser.
was talking, instead of double quotes, use single quotes.
Use single quotes to just
Because
complete.
dash, well, weren't you saying that dash can add it inside the double quotes?
Yes, bash will leave this alone completely,
Yeah.
but I still have to escape it from grep.
Mhm.
There you
Yes.
go. So I got the same result. Yeah. Still have to escape it from grep. Okay, so didn't answer a question though. I didn't get my line that matches left bracket, ABC, right bracket, but I know how to do it now because I can do this. Okay, remember what does dot mean? Match any single character. What does plus mean? It's a modifier. One or more instances of the thing immediately to its left, which is anything. Dot plus is the equivalent of star in cloud body. What I do wrong?
This is not gonna give you your bracket.
No, it'll give you.
Oh, I know. I want bracket ABC bracket. That's what I'm trying to do. But you did. Thank God.
Now,
Dot plus.
Now,
is
if
it-
you change your plus to an asterisk.
Oh, 0 or
then you
more.
would get
Yeah.
Both bracketed.
Yeah. Be careful. And again, I'm going to continue to harp on the cloud body. Okay. Dot plus is the closest thing you're going to come to the way we know file blotting works in regexes, because it means one or more instances of the thing to my left. It's not perfect. I'm not saying it's exact, but it's close. The dot star, though, that you almost never want to use that, because what does it mean? 0 or more instances.
So if it's a condition, you're gonna have 0.
And in this case, we do.
You're going to get a.
Anything with bracket.
But you don't know if
Well,
the
this
data
would,
always
it would
have-
work, yeah.
Anything with something to bracket.
It would also match my bracket by itself, right?
Yes.
You can also do
And there you go.
alpha num.
Yeah.
L num would probably be better.
Just be careful with this one, because this is the dot star is a great example of making your regex too greedy. It will match what you want and probably more than you want. So
In this case, this is
this case is fine. Yep.
cat test, and you do the same thing.
Yeah, yeah. The most complicated way to say cat test. I'm gonna alias the cat. This will be
What do they call those things that have like 27 steps in order to get?
Rube Goldberg. This is a Rube Goldberg cat machine. I love it. Love it, love it, love it. Okay, so that's the first two uses of parentheses. Grouping. I want to use a modifier on something other than a character. I want to create this whole complicated BS and then apply a modifier. Or I can use the pipe command to indicate or. And this is different from the character set, right? Because that's just a character. This can be big. This can be anything. And in fact, as we saw, these can be regular expressions of their own that we can nest inside there. And then finally, just when you thought it was a little complicated, we have back references. Okay, this is the last part we're going to talk about regular expressions tonight. There is more, but this, once you master this, you got probably 90% of it. Okay, so the best way to explain back references is through an example. So we're actually going to step away from grep here for a second, because back references don't really work with grep. What we're doing here is when we need to use a regular expression to replace text. Okay, let's use a simple example here. I'm going to cap my test file. We've done this. I want to replace every instance of A with capital A. Let's make the simplest one possible. Okay? TR would do it. We're going to use sed though. Search for, remember the syntax for this, search for, what's my regular expression? A, replace it with capital A, and do it globally, which means don't just stop at the first one. Okay, this looks like Greek, but that's what this means. You're actually passing 4 arguments to sed. The first one is, what are we doing? Search. What are we searching for? A. What are we replacing with? Capital A. How often are we doing it? Global, to all of them. I'm doing the single quote here. I probably don't have to. Some of this stuff I've just done for so long, it's become muscle memory. I probably don't have to. I know this will work. We'll try it without. Yeah. All instances of lowercase a anywhere in the line have now been replaced with uppercase a. Did it actually modify the file itself? No, because I'm just catting the file. If you actually want to do that, there's a couple ways to do it. The poor man's way would be to redirect this to some weird file and then move that over this. Or sed actually has the option to edit files inline -I. We're not going to do that. Okay, one thing we do need to bring up though, back to the whole extended regular expression thing, sed is the same as grep. By default, it does not employ the extended regular expression library. You have to pass an argument to sed to get it to do that. Remember what argument we had to pass to grep to get it to employ the extended regular expression library? What was it? Capital E. Capital E. Therefore, what is the argument we passed to sed to get it to do that?
No R.
Dash R. Just frickin' dash R. Because the authors of these tools hate us. R stands for you're never going to remember that. You have to look up a manage every single time. We're going to get the same result because we're not actually employing this.
It's not recursive?
Yeah, it doesn't mean recursive sed. Okay, so a back reference means not only do I want to match something and replace it, but I want to reference what I matched in my output.
Okay. So it's like a variable.
It's a little contrived. It's a little like a variable, right? I'm going to store a variable and reference it later. So you kind of have to, unless you have like a real world example to apply this, so you have to come up with a little bit of a contrived example, which I've done so in my notes here. Okay. So I'm going to start with a file that has phone numbers. Okay, standard 334. Okay, I want to change this, so I put parentheses and a space around the first 3. Pretty normal, right? So without cheating and looking at my sed there, let's actually create this. Phone.text. It's my cell phone number, by the way. Yeah, it's no secret. Here's my home number. I'll call it, my wife will answer. And here's the 800 number for Super 8 Motels.
Some guy answered.
Son. Okay, so there's three phone numbers. I'm going to cat this, and I'm going to say, after I pay skill tax, I'm going to say sed search for. Now I forgot what I typed. I have to wait. Okay, well, I'm going to do -R, just so there's no question. Just spend the memory, I don't care. Then I'm going to say sed -R, search for, I want to say the first three numbers. So start putting this regex together. So I said first, right? So caret, anchor the line. Now I want to say the first 3 numbers. How do I do that?
Bracket, colon, or whatever, digit, whatever it is.
Digit, thank you. I couldn't think of it. Yes, this is one way to do it. Using a named character class.
Colon,
do this.
colon.
bracket,
Okay,
and
and
then parentheses, or
Well, I want 3.
curly brace
Curly
3.
brace 3.
There you go. This is one way to do it. Remember, the curly brace 3 is a modifier. It says give me exactly 3 of the thing immediately to my left. What's immediately to my left? It's this named character class. Okay, this will work. There's lots of other ways to write this. Well, there's a few other ways to write this.
Do I have to deal with
You could do this.
plus ones and stuff like that?
Well, we'll get there. You can do this. This, I think, is a little more readable, right? If you really want to be, I don't know, pedantic about it, you can do that. So have I. This is super readable. This is pretty easy for human parts. I like this, okay? We're gonna go back and we'll do this. Whoops. Okay? No anchor on the end because, well, I mean, we could do something like this, right? You don't really need to, because if we're just saying, I don't care, I only care about the first part. Now, if let's make up a situation. I want to replace all these with 9s. I mean, yeah. Okay, so to prove that works, search this file, match every line that starts with a digit, exactly 3, and replace those 3 with 3 9s. Now, it doesn't have to be exactly 3. It could be this, and it would still work. Okay, there's no like one-to-one matching here. It says take this. Says take this and replace it with all of this. Okay, simple enough. But what I really want to do is I want to say, just put parentheses around those first 3. Well, the only way I can do that is by what's called a back reference. So let's go back to my slide here.
And so you need the -R option of set to get to that.
Yes,
Okay.
that's a good point. Back references are included in the extended regular expression library. It will not work unless you include it. So we're catting phone, passing the set-R, search for. Okay, this looks pretty similar to what we just had. What's the difference? Parentheses. This is the important part. This is the third usage of parentheses. The first one was grouping. The second one was letting the pipe stand for or. Okay, the third one is back references. So what the parentheses, because I mean, forget everything, forget this.
Yeah, but we'll look at that.
If we just did this, you say, that's a completely unnecessary usage of parentheses.
Yeah.
We don't need it, right? We're grouping this for no reason. And you're right, but we're grouping it so later in our results, we can reference it.
And so the first time we do it, it's a 1, the second time a 2.
Bingo. So think of this like a variable. We have essentially assigned the contents of these parentheses to variable number 1. Said, for whatever reason, you have to represent the variable as \1. That's said specific, other regular
And that has to
expression.
be in a parentheses?
This, well, no, I want my output to have parentheses in it, remember?
Oh, that's what
My end result should be parentheses for the 2. Yeah, I know that's super easy. But welcome to regular expressions. They're super good. This is said
These are
specific.
not the parentheses you're looking for.
other programs that incorporate back references. In fact, the only one I can think of off the top of my head is the Apache Rewrite Rules Library.
Oh.
Use a different syntax to indicate this. Apache does $1, because God forbid we have a standardized script.
XRs has that kind of reference.
XArgs does,
Well,
well, not back
it's a
references, for
reference.
variables.
Yeah, very.
Oh, you're right. It does the same thing. You put it in parentheses, you reference it later
I
in
don't know
XArgs.
that way, but I think.
And it's $, right?
B or something like that.
I don't know. I've done that once. But yeah, the point is, it may be different between applications. But in general, just remember what you're doing. You're defining what I want to reference later with the parentheses. And then depending on what your application is, you may have to do some stupid syntax. But the point is, you're referencing it by an incremental number. Number 1, number 2, number 3, number 4. You do that instead with the backslash.
You've complained about the program authors a few times. You should thank them for it being 1 instead of 0.
Yeah, right?
Should I thank them? I mean, don't we start counting at 0 as computer scientists? Yes, good point.
And I'm expecting to be $1, so I'll put $.
I know, right? Every variable is a $. Okay, so and this is okay. So first, I have to define my group, right? And this is my group, right? Let's make sure I'm writing.
Do you look at the XRs thing? Is it a big B?
Is there a way to do grouping without back references? Because I think you only get 9 of those variables to store.
Is there a way to do grouping without back references? Well, the whole point of us doing grouping here is to use back references. But I see where you're going with that. What if I need to have more than 9 back references? No idea. Never been in that situation.
This is your exercise for home.
That's your exercise from. Come up with a legitimate reason. Yeah, that's a good question. I don't know. I don't know. Okay, so let's see if we got this right first. Set-R, search for, caret, start my grouping, all numbers, exactly 3 of them. Then replace with an actual parentheses, an actual honest God parentheses. Remember,
Is that space?
it is this, well, I don't know why. I should probably do
There's a
this.
space behind the 402.
There, how about that?
Okay.
What a dash, 402 dash.
You didn't need your dashes, absolutely.
We can do that next.
We can.
Remember, the word grep, G-R-E-P, that's the argument you're passing to set. The R stands for regular expression, right? The E, just expression. So my parentheses here in my, I guess officially my third part of my set argument, I don't have to escape or do anything weird with because it's not parsed like a regular expression. Okay, so how do I, that was dumb, I should have done that. How do I put a dash, let's keep the parentheses. Let's move this dash after the first 3. So it actually looks like a phone number.
You could either go to the next 3 or you could grab the last 4. I'll grab the last 4. I don't know why.
Okay, so I'm searching for, let's get rid of all
Oh,
this.
yeah, last word probably.
Then I can do the dollar
I'm
sign.
searching for this. There's my first group. But then I want to say, I'll just do the next 3. 0 through 9, so same thing, right? Why am I doing 2 of these? Because I want to reference them later as 1 and 2.
Right.
Now I say, give me 1, and then we'll do a,
Yeah.
then we'll do a space, then we'll do dash.
Yeah.
Or I'm sorry, the next 3, and then the rest of the line.
Yep.
And then a dash or something.
Slash
No,
go.
we gotta.
Ah!
Slash go.
Forgot what I was doing.
Your battery's low, it's 5%.
Ooh, it is. I better talk faster. There you go. It worked. A little bit of a contrived situation, right? Not something you're probably going to do every day. But when you need to do it, by God, this is the only way to do it.
Real life example of having to redact shadow. That's a shadow.
Having to redact it?
So that, yes. So that we have to get a screen, real life example on it. Needs a screen capture of Etsy shadow. I don't want to give them full Etsy shadow. So I need to redact the hash out of Etsy shadow. That was a fun exercise.
Oh, that's really good.
Because Etsy shadow has $6, $1 is part of the.
We're going to show all the internet my password. Oh, I don't have a shadow file. Yeah, I did. There you go. There's what's hash.
So yeah, $6, something. Yeah, $sign each.
Here, we'll do my son's. I know his password.
So you retract the hash?
Yeah, so I replaced the actual hash with a bunch of stars and say redacted a bunch of stars. Okay.
Nice.
Is this a video?
Sure. I'll change it later. Ethan never logs into the system. Great example. So here's an actual honest-to-God Etsy shadow file from my server at home, actually, it's my son's. So crack it as you will.
Yeah,
So I want to, so this is good. So I'm gonna grab it, I'm gonna say set-r. I want this line, but I want the password replaced with just 4 X's.
Sure.
I mean, the easiest way to do this, since this is a colon delimited file,
yeah,
and there was not a colon in my data,
okay,
is to use cut, right? And then give me field 1, 3, 4, 5, 6, 7, 8. Skip field 2. I guess that didn't exactly do what I wanted because it just skipped the field and didn't replace anything else. Okay, so let's actually go back to set and do this. Set-r, search for any dot something, dot star is something, or dot plus, sorry, something, and then a colon, and then something, and then a colon. I should anchor this, right? Anchor. Will that do it?
It'll do something.
No, it won't, because I have to reference this later.
What are you gonna do about it?
So I have to do this. Actually, I don't need this. Oh, wait, no, yeah, I do.
You're gonna reference that. and
Yeah, I do, because I'm gonna,
You're gonna reference 2 and replace 2 with.
but I don't want to reference 2. I don't want, I want to replace it with like all X's.
Right.
So I don't want to reference it.
Oh, that's the point.
You know what I mean?
Yeah.
Okay, I don't know how to do this, I'm thinking.
Do it the same way.
I solved it. I forgot how I solved it. I think I ended up
That's
using
fine.
I'd probably just look for the colon dollar.
I can't guarantee it starts with dollar.
All hashes start with a dollar, don't they?
Yeah, they should. All legitimate hashes.
Oh, okay, so I could cheat and do that. That's
The
fair.
tricky part was having, some of them have special characters, other than alphanumeric. And it's like you got the dot between the 4 and the Z. And that broke a lot of my searches or a lot of my patterns that I was using.
Oh, interesting. Okay, I know the way to do it. This may not be the most efficient, but I know the way to do it. The shadow file is a defined list of delimited fields. How many is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 fields. There's 8 columns in this line, so it's 9 fields. So let's just, every line is going to have 9 fields in it. So let's go with that. So I'm going to say, match.
Yeah, I use pop.
There may be, there may be a better way to do this, but this is one way to do it. I'm just literally going to define all the fields here.
And then pick the group that you want to change.
Right. And then when I print it out, 1, 2, 3, 4, 5, colon, 2, 2, 2, 2. How about I do this?
And curly brace 9, curly brace wouldn't do it because you wouldn't be able to reference them.
Right.
Why?
I don't think so, because that would be combining 2 different definitions of the parentheses.
Okay, yeah.
One is group and one is background.
So you need
I've
2
never
sets
done
of
that.
parentheses. 2 sets of parentheses then?
And then you double escape them all, yeah.
Well, I don't know, you need to double escape them.
1, 2, 3, 4, 5, 6, 7, 8. Let's try this first.
Yeah.
This is 9. Did I get it right? Okay. Ethan's first one. Long password is the second one. 3, 4, 5, 6, 7, 8. Well, that should be. I'm not sure if that. We'll see if this works or not, because I don't know if there's a field after that last colon or not. So, and I'm going to end this. Okay. So, search for 1, 2, 3, 4, 5, 6, 7, 8, 9 fields with a colon in between. 1, 2, 3, 4, 5, 6, 7, 8 columns, and replace with, now spit out field 1 and then a colon. And then instead of field 2, 4 X's, colon. And then field 3, and field 4, field 5, field 6, field 7, field 8, field 9, colon.
Didn't complain.
Actually, yeah,
It didn't complain, that's interesting, but it didn't work.
it's not.
Awk, man.
Oh, yeah.
Awk is
Just his awk for the way. You know where awk got his name?
Yeah, but the 3 guys.
Yeah,
that come up with it.
The W guy works at Google.
That's it, really.
It did not do.
The first dot plus sucked up all of the line.
So give me all characters.
You're right. It did. This is way too greedy, isn't it? Because the first dot plus means match anything, including a colon. So that first one matched the entire line. How do I not make it do that?
You match only 3 characters. Instead of plus squiggly.
I hate having regular expressions that are very, very data dependent. Because then as soon as the data becomes something that I didn't think, my regex breaks.
Right.
But you're right, I could say, hey, this is usernames, it's always gonna be this, right?
Match everything except for a colon. Do a not colon in there.
Ooh. Okay, so like that?
Not colon and then dot.
Or what I mean? Oh, no, 1 or more. Right? 1 or more.
This is getting
Not
weird.
cool.
Okay, start of the line parentheses, negate the colon, as many of those. So we gotta do that for all of them, right?
You gotta do it for at least the second one, too. You don't care if you get
Yeah, you
the
just
rest of them.
group the rest into one group.
You're right, because I'm just gonna, oh yeah, I don't have to have, after the password, I don't care. Plus. And then,
You can leave them, but
maybe it's a bandwidth thing, because I'm remote, maybe that's why I'm getting the skill tax.
Then regex to edit this regex.
Yeah, no kidding. Okay, this is gonna look a lot cleaner when I'm done with this, because I don't need all these.
Ethan's probably playing Minecraft this week.
You only have one core.
This isn't actually very big system. It's got 30 terabytes of disk. So let's run through all this.
5400 OPM.
Oh, they're 72. It's not the fastest thing on
But he's SSH in, so that
yeah, that's why.
it's locally that it's spinning.
Okay, so match first, match second one, and then after this I do colon and then anything, right?
Okay.
And then anything, and then end of line. So now I don't need as big of a string to end with because I only have 3 groups, 3 back references, right?
And spit it out.
Username, password, everything else. So I can go back here
Change it just 3 groups.
and just go to 3, right? I'm gonna die if this works. Never works on the first try.
You still
I
have
don't
to.
know if we need extra colon noise or what.
Is that right?
That's right.
We'll find out.
Try that. I wanna gotta use my brain a little bit. Okay, not colon, one or more, not colon, and then a colon, one or more, not colon, which is 2.
yeah, we'll probably get extra colons.
It would,
Why didn't we get extra colons?
I told you, because I said not colon.
Yeah.
So we just use the 3 groups.
Okay.
Yeah, and then my output is group 1, and then colon, all X is colon, and then group 3. Group 3 being
Everything.
the rest of the line, right? Because I defined it here, dot plus, which is
Yeah.
a single character, 1 or more of them. See, this is where you could have another regular expression that would give you the same results in this case, but this is too greedy. Now this would never happen, but this would also match a line that just said Ethan colon, password string colon, nothing, which of course would never happen. But a good example. of a
Bad shadow
situation
file
where-
still would work.
where, yeah, you don't want that. You always want plus, dot plus instead of. That's a good one.
I don't want to
Go ahead.
capture your.
Yeah, it's about to change Ethan's password anyway. That's fine.
Well, no, I don't, yeah.
No, you're good.
Don't give a password, it's just the example.
Yeah, no, that's really good. This is a great example. This is where back references are powerful. There's really no other way to do this without back references because you're referencing something you matched in the output over here.
Now, you said earlier there are only
But that's like
9,
saying C is the answer.
there are only 9 groups. Is that something you're assuming, or is that something that you know?
Well, I've only ever seen it documented for single digit references. Because like if I did / 10, I would think it would just parse it as 1.
Well,
I don't know.
And then put the 0 in.
And then if you use 0 as a
In
character.
Dash, you can do some kind of an escape to get to the 10.
Right, or maybe I can group it
So
somehow.
they're
Yeah.
making some syntax that allows you to have more than 9.
I've thought about that a bunch whenever I come across this. I've just never been in a situation where I needed it, so I never investigated to know what would happen.
It's
I had to
actually-
match 10 groups.
It's actually hexadecimal. You could be.
Just go to A and B and C. Just put it off a little bit longer. Oh, great example, you guys. That's awesome.
I see you're probably gonna update your slides with.
I know, actually. So imagine somebody new walking in and looking at this screen now, like, what in God's name are they talking about? But this makes sense now, right? We actually know what this means. Look at this. Before tonight, this was all gobbledygook, right? But we actually know what this means now. You just have to sort of get in the mindset, parse it left to right, think like the parser. Remember that bash is the first parser, and then in this case, set is the second parser. You have to know, you know. Oh, one nice thing about set, this slash for a delimiter with set is actually dynamic. It's the only application I know that does this.
I use commas a lot.
Yeah. So what that means is sometimes you want to match a slash inside your regex, and that really confuses set because that's the default delimiter. But you can tell set to use a different delimiter, and the cool thing is you don't even have to do anything weird to do it. You just use a different delimiter. And set will go, oh, you must mean this. I'm just going to use underscores. Eventually. You can see it go. Isn't that cool? Set's smart enough to just say, oh, you must mean underscores with letters. I'll jump right on it.
Oh goodness, so forgive me.
Yeah, that's the only complication. No, you don't have to like pass it like TR, you have to pass what the delimiter is, awk, you have to pass what the delimiter is. This is very, just does it. So that's cool.
The very first parameter S, there's several options that you can use there. Are they all single characters?
No, I've seen examples of like S1-10, like only work on these lines.
Okay.
Yeah, that
I
can be
mean, I was
helpful.
thinking that you
Oh,
tag the second character as the delimiter is.
oh, I see. No, I've seen more. I've seen more than there. I don't remember a time when I've ever used it,
Looks for the keyword,
but I've done it.
and then a string, and the next string.
Yeah, that's a good question. I'm not sure how that parser works. It's smarter than I am. So, yeah, that looks like a bunch of. It looks like a cat walked across the keyboard.
Always look up the
But-
source code and let us know.
It actually works. That's pretty cool.
I could,
So,
but I'm not going to.
Don't be afraid. So don't be afraid of regexes. They're there to help you. They can be a little crazy. They can be a little wild, and it's a little hard to parse, but they actually work. Oh, I had one. We already did a much better real life example than this. But we can look at my real life example if you want. It's my very, very simple email parser that I wrote 100 years ago. Remember this, John? It's a shell script. So it's got a little bit of shelly stuff in it, a little bit of IO and little logic. But the point is down here. So this is from the grep command down here is one big long single command. It starts with grep. So the very first thing we're passing the grep is, hey, look, it's a very simple regular expression. Notice this isn't egrep or grep-e. So this is a very simple regular expression. Caret capital from colon. Show me every file. Show me every line in this file. File being $1, which is you have to actually pass the file to this command line. So this is designed to pass an mbox file, standard Unix mailbox file. Grep for every line that starts with capital from colon in this, and then pipe that through egrep-vi. V means show every line that doesn't match the following. I means case insensitive. So I don't want anything that matches any of these words. Balance, mailer, plus. I don't want any of this crap. I'm pulling out human email addresses was the goal of this. So this is just nope, 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 nope. And then finally, and again, I'm sure there's 9 different better ways to do this, but this is just the way I did it. Pipe again to grep-io. I remember case insensitive. O means do not show me the entire line. Only show me the stuff that matches. No, notice that there's no position delimiter here, right? The email address can occur anywhere in the line. So the first thing we see is bracket character set, right? What's in my character set? A through Z, capital. Doesn't matter, right? Because I did the dash off. 0 through 9, or a dot. Now, does the dot here mean a regular expression, or does it mean a period?
Period.
It means a period, because it's inside these brackets. I know, that's confusing. A through Z, 0 through 9, or a dot, or an underscore, or a parentheses, or a plus, or a minus,
So printable?
and character.
It's the allowable characters in the first.
It's a little bit less. I actually got this from the email RFC. These are all valid characters you can have in an email address.
Okay.
Not every email validation web app honors that.
On the left of the app.
On the left of the ad sign, parentheses in particular, some web apps will go, that's not an email address, you suck. But actually, the RFC says you can have it. And then, so what does plus mean? One or more instances of the set of the thing to the left, and the thing to the left happens to be a set. So any of those, one or more, and then the at sign. And then this clearly is old because this is way before the TLD opened up. And if you had $175,000, you can buy your own. So these are the ones that were valid back in the day. Let's start to the right. Well, first it's a parentheses, right? So it's a grouping. And we're using pipes. So this is or, this, or this, or this, or this, or this. Museum of Jobs, agent here, all these valid TLDs. But then here, A through Z, exactly two. These are country code top level domains, right? .us, .uk, .fr, right?
Yeah.
CO, yeah. Or com, TV, or com.
TV.
And then finally, piping it to the TR command. TR stands for translate. It translates a single character to another single character, but it also understands character sets. This says take all the uppercase letters, make them their lowercase equivalent. So just a little lowercase letter, sort of unique it. There's your email address system. Okay. So a simple shell script example of how to use the regex stuff we just talked about. You know, your random text, this will pull all the email addresses out of it, spit them out one per line. And then you can do whatever you want.
I like your comment there that explains what the expression does.
The code was hard to write. It should be hard to
You
read.
should be able to read it.
Oh no,
That
that one's pretty easy compared to the ones I've seen.
Yeah, well, like
Yeah.
on this first slide.
In fact, there's a whole website dedicated to just this. It's called emailregex.com. Literally, because so many people have solved this problem over and over and over. They talk about kind of how to do it here. And it's a pretty easy read because it's one of those things where you'll come up with a regex that's pretty sane, not like mine. It'll capture like 99% of them. Then if you want one that legit covers all the cases in the RFC, it's like this. It's crazy. Because the RFC is actually pretty good. It's just nobody ever uses it.
Yeah.
It is,
Yes,
It's a little hard to parse.
it's not in stone.
Railroad diagram of the above projects.
I don't even know where to start. I don't even know where to start with this one. Well, first, I don't know what the heck question mark colon means there. That's something special with regexes. I've never gotten there.
Well, you said question mark is 0 or 1 of the modifier parentheses, so.
I don't think, actually, I don't think it's being used in that way in this case. I think there's something special about it being first inside of parentheses. I honestly do not know.
Well, if they're explaining it in that diagram.
It clearly shows.
It's an exercise for the reader. Sorry, guys, I do not know.
Question mark exclamation point is the exclusion or I was trying to solve our other problem of give me everything except for.
Oh yeah.
Problem, and that could,
but exclamation point is not actually used in my experience as a regex special character.
I was looking at regex101.com.
Oh, okay.
And it was in the help file on the side of that.
Interesting. Okay. Well, maybe just not the way Greg interprets it. I mean, there's lots of different ways to use rejexes. Yeah, I'll look at that.
It's cool stuff.
Yeah, there's all kinds of good resources. I was actually looking at one earlier. What did I search for? I think I just did the regex website. Yeah, regexr.com.
The second one down is the one I was on.
Okay. And so I played around with this a little bit, and the problem is, it very much depends upon your interpreter from a syntax standpoint. A lot of these are assuming that you're doing this inside of a programming language of some sort. Like, for example, this slash is hard-coded in this, that assumes there, and this \w plus, also, I think that means like word.
If you look at the other one, you can pick your, the one below.
Regex 101.
And on the left here, you can pick.
Nice. Okay, what flavor of regex you want? PCRE, that's actually the one that Perl uses as well. Yeah, I guess I don't know which one we were using, but there you go. So you can test them here. Or just test them with grep like we just spent the last hour. But that's cool. And, yeah.
In the quick reference, if you type in exclusion, I think, or that's where I found the, in that search reference, go to the.
Oh, type the word exclusion. Thanks.
They excluded it.
Yeah, and again, that's what I was looking for.
Starting at the current position in the expression ensures that the given pattern will not match. Does not consume characters. And then not bar.
A negative look ahead.
Oh, Jesus. Yep, and that's why I stopped right there with my real expression.
Thank you, Adam.
Thanks, guys. That was fun. That's good. Well, I'll share out the pre-show with everybody if you want to take a look at that. And, yeah, feel free to comment. I need to update the slides for some are good examples here.
Are you gonna update them before you?
I will, yes, I will. I'll just share this with everybody so everybody can read it.
So next month is the holiday party.
Woo! We buy beer.
So bring snacks with you to that evening. If you want to do a lightning talk, you're more than welcome to. Maybe I'll look up a quick one on flat packs.
Yeah, that'd be
Next month.
interesting.
So anybody who needs to can certainly just, it's like 10, 15 minutes, you know. Not an in-depth 2-hour regex expression.
A deep
Which was an expression in itself.
A deep dive.
How Adam does his presentation. So,
Randomly and with little preparation.
yeah. But you're always so into it, and everyone is fired up and
Good audience.
yeah. So, I'll end the recording, and to you.
All right. Who's going to the bar? That's a big question.